Hi everybody, I'm Professor Rad, and today we're going to talk about how you can use a t-score to find a confidence interval. In the last video, we used a critical value of a z-score because the population standard deviation was known. In this video, the population standard deviation is not known, so we'll have to use a t-score. I'm going to start out in much the same way as I did before by reading through the paragraph and summarizing what information I know. So it starts out by saying, the sample of ages below, measured in years, comes from a population that is known to be approximately normal. Let's create a 99.9% confidence interval. Then it says round all interim values to the nearest thousandth. And your final answer to the nearest whole amount. And then we have a sample. And that's it. So they did not give us a whole lot of information in this problem. Sometimes they might give you more information than this, but in this case they did not. I wanted to do an example that was kind of like a worst case scenario for us. So all we really know right now is our confidence level is 99.9%. Oof. Well, the least we can do is summarize some of the letters. So we know that point estimate means X bar. Standard deviation they want is S. And I'm going to put S here because they didn't tell us sigma. We don't know anything about the population. So our standard deviation will be S, which means we want to find a t-score to solve. So our critical value will be T. And our margin of error is always E. So we can at least kind of fill in the letters. So the next question is, how do we start filling in some numbers? So the good news is they gave us our sample. So we can find our sample mean and our sample standard deviation. And there are two ways you can go about this. So to find a sample mean, you can add them all up and divide by however many there are. That will get you X bar. And to get your standard deviation, you could create that table where you had all of your X's and then X minus X bar, and then you square them all, and then you divide by the square root of, or you square root the quotient of the total and n minus 1. So you could go ahead and use the formula. Or we can put technology to use, which is what I'm going to do. So remember that every calculator has a different way of finding summary statistics. On this one, I'm going to go to data, and I'm going to type all these numbers into this first column. So we have 5, 11, 17, we've got 2 14s, and a 19. All right. So then I'm going to quit out of here. And I'm going to look up my information. So I want my one variable statistics. And here we go, we've got our data. So we're rounding these to the nearest thousandth because these are interim values, they're not our final answers. So X bar, we have 1, 2, 3 to the nearest thousandth. So we'll get 13.333. And these are ages that have been measured in years. And then I need my sample standard deviation. Now, do not be fooled by your calculator. Your calculator knows less than you do. Your calculator does not know if this data is for a sample or for a population. So it's always going to give you both S and sigma. We need to know that this is for a sample. So we don't use sigma, we're going to use S. And so to the nearest thousandth, 10th, 100th, thousandth, this 1 is going to make the 6th day. So we get 4.926. All right, and there you go. So we have found our X bar and S. Now, I think what I'll do, if you don't remember how to find those values on your calculator, if I remember, I'll put a card or a link somewhere, maybe in the description, to the video where I go through finding single variable stats on several different calculators, just as a reminder. Now let's go ahead and find the rest of the information. So let's find our t-score. To do that, we need our degrees of freedom, which is n minus 1. They didn't tell us n, but n is the sample size. It's how many numbers we have in our sample. So we have 1, 2, 3, 4, 5, 6. N is 6. So for our degrees of freedom, we're going to do 6 minus 1, which is 5. And then we're going to use our t-score table to help us out. We're using 99.9%, so we're using this column all the way on the right. And our degrees of freedom are 5, so we're going to be looking in the row for 5. So all the way to the right, we've got a decently large t-score here, 6.869. Now, just like with z-scores, t-scores do not get labeled, so we just keep that as 6.869. All right, for our margin of error, the formula when you have a t-score is going to be your critical value of t times your standard deviation of s over the square root of your sample size. So we're going to do 6.869 times s, which was 4.926. And we're going to divide that by the square root of n, which we found was 6. So 6.869 times 4.926, divide that by the square root of 6, and we're going to get 13.813,77248. Okay, so to the nearest thousandth, because this is still an interim value, the 7 makes the 3 go up. So we're going to get 13.814 years. All right, we are almost done. So now for our interval, we're going to do x bar minus e, x bar plus e. So x bar was 13.333. Remember, you're always going to do minus first and then plus, because we want these in order small to large. And we've got 13.814. Now, the interval is going to be our final answer. So our final answer gets rounded to the nearest whole amount. 13.333 minus 13.814. Oh, so that gives us negative 0.481. So this 4 is going to keep that 0 as 0. So we just get negative 0, but that's the same as 0. And we were labeling things with years. This is a sample of ages. And then we'll add. We get 27.147. So to the nearest whole number, that 1 is going to keep that 7 the same. So we just get 27. Okay. Yeah, so the range of ages that we would expect the average to be in would be from 0 to 27. So this isn't really helpful if I'm trying to if I wanted to say what was the mean age of the people who attended that movie? 0 to 27 is a bit of a bit of a range to get for my mean. And we're getting such a wide range here for two reasons. Reason one, our standard deviation was kind of large based off of our mean here, but also our t-score was really big, and that's because our confidence level is really high. So remember that the bigger your confidence level, the bigger your margin of error, the wider your interval. Okay, so the less precise it is. So to summarize our findings here, we can conclude with 99.9% confidence that we don't know too much information about this, just that it's a sample of ages. So we have 99.9% confidence that the mean age is between 0 years and 27 years. This means that the probability that our interval contains, remember you need the awkward language, the interval contains the true mean, age, because that's the context, is 0. And since we have 99.9%, 999. All right. So that is going to wrap it up for this video. I did want to point out that sometimes with your t-score questions, it'll be similar to this, where I give you a data set and you have to find x bar and s. But just as with z-score questions, like if I look at some of these practice problems, you might be given that information. So for example, here it says mean height of 63 feet, standard deviation of 3.5 feet. So sometimes you're given that information, and sometimes you need to find that information using either formulas or your calculator. All right, in the next video, we will talk about things like, this is a really small sample. That's also probably impacting why our interval is so vague. So if you want an interval with a certain amount of precision, how big of a sample do you need to find? So that's what we'll talk about in the next video. I hope you found this one helpful, and I'll see you next time. Bye, everybody.